everyone. I think we'll get started here. It looks like we've got most of our attendees logged in and joining. Thank you for joining us this lunch hour for WGI's Lunch and Learn series. I'm Angela Biaggi, the Director of Urban and Community Planning with WGI. We're thrilled to have you join us here today and eager to connect with some of our professionals who are driving the growth and results for us here at WGI. And in the case of today's presentation, two of our professional colleagues. WGI is a multidiscipline professional service firm leading our profession in technology-based design solutions for the construction of public infrastructure and real estate development. At WGI, we like to say that we're providing tomorrow's infrastructure solutions today. The built environment and the process by which we envision, design, and build infrastructure is changing faster than ever. With nearly 600 professionals spread across 18 offices in some of the most desirable locations in the country, we're at the leading edge of this sea of change. Our aim for our client Lunch and Learn series is to provide value to our audience in an open forum and a platform where our professionals can begin the process of lending their expertise to your development challenges. With us here today is Lisa Nissenson, our Vice President of New Mobility and Connected Communities with WGI, Alexander Esposito, the CEO and co-founder of Circuit, and Jennifer Foote, the Vice President of Customer Service and Success at Beep. As we visit today, I would encourage you to ask questions at any time in the Q&A or the chat tab on your Zoom browser. We'll be reviewing these questions as they come in, and we'll do our best to answer them directly before the session ends. So what are programmable streets? Why do we need to rethink how we design and manage our streets? Today, we're going to discuss how we can physically program our streets using modular infrastructure and flexible street design. Lisa's going to discuss how we can use digital infrastructure and technology for street design and operations and the current shift in revenue capture along our streets. And we'll hear from our partners at Circuit and Beep on how we can better program our streets for new mobility. So why programmable streets? Well, humans don't do the same thing throughout the day or every day. We move, we change, and our public spaces should be changing with us. So streets, and if you really think about it, streets don't do the same thing throughout the day either. We've seen that the increase in innovation is really putting more vehicle types on the roads, trails, sidewalks, and curbsides. These can be mixed motorized and mixed speed vehicles with or without drivers. Some small autonomous delivery vehicles are also in the mix on roadways and sidewalks, like the little Starship robot at the top right here. In Pennsylvania, there's actually a new law that's classifying these delivery bots as pedestrians. And with a max speed of only 4 miles an hour, maybe that's appropriate for the sidewalk level, but we also need to consider the scooters, the shuttles, and the mopeds, which can go upwards of 20, 30 miles per hour. So we really need more tools at our disposal to manage the traffic and the uses. When we talk about programmable streets, we talk about both the design and the management of our streets. So our typical street here at the top operates the same way every day, all day. Maybe it's efficient, maybe it's not. Travel lanes are used the same way regardless of the amount of traffic, and the pedestrian space is delineated by the edge of the curb to the building face, no change. A street that's programmable is flexible and can change with the needs of the day. So in the peak morning, maybe there's a dedicated lane for transit during the morning rush hour. In the afternoon, maybe more area can be opened up for pedestrian and cafe dining with less of a priority and less of a demand for vehicles. And in the evening, maybe the lane's direction could reverse to manage the PM rush hour. And Lisa's going to talk a little bit later on how we can use technology to accomplish this. And we've seen what happens when streets are static and there's this competition for space. In just this example alone, you can see the competition for seating, landscape, parking, dining, shade, advertising, lighting. And who's really losing here? And who, when we try to do this all in one for everybody, it's the main user in this case, the pedestrian. Here we've got 3 pedestrians trying to navigate the sidewalk and it's not ADA accessible. From an economic standpoint, programmable streets can be really successful drivers of revenue as well. These are statistics from Texas, where a downtown Dallas street on-street parking space costs $1.50 an hour. If that space is full from, say, 7 a.m. to 6 p.m., it generates a revenue of $16.50 in parking. By contrast, if that space was converted to a dining parklet at key points during the day with multiple seatings, it could generate upwards of $300 in potential revenue in dining tickets alone. So now I want to take a little bit of a deeper dive into how we can physically program these streets. And we learned a lot about this and the importance of this in the last year in physical programming during COVID. So the picture on the left is Clematis Street here in downtown West Palm Beach. Shout out to our friends at Dover Cole, who did a wonderful curbless design for this entire corridor. And with this, the city was able to very quickly and rapidly and successfully implement an outdoor dining program on this new street design. I don't know if they really envisioned that to what level it was going to be used or if it was going to be used in this way, but it worked. And the ability to successfully and quickly pivot the uses of our streets is so critical in making our cities resilient. And maybe ultimately these temporary changes that have been put into place for social distancing will be transformed into a more permanent solution, kind of like the image here on the bottom right. And we're really seeing a growth in availability of modular and liftable infrastructure to aid in the programming of our streets. So on the top, we have a couple planter options. One is being used as a bike separator. The other is being used to define space in a plaza area, but both of these can easily be moved and relocated with a small forklift. We've seen the use of temporary bike lane delineators, as well as charging stations for scooters that can be moved based on demand and need of the area. And to limit vehicle access, here's a couple examples of how we can use movable fences and separators. The top is just a fence that can be simply pushed and rolled around by hand. It's on wheels. The picture on the right is more substantial planters that swing to open and close the road as needed. And of course, we can use retractable or removable bollards for this as well. And programming isn't just limited to the front of house. It can be expanded into the back of the house or alley spaces as well. This is an activation of an alleyway that was done in Michigan, which took underutilized parking spaces and transformed them into a pop-up demonstration area. While some of these items could be considered a little more permanent, the space used movable planters and temporary bike stations and temporary lane delineators as well. Pickup and drop-off and deliveries have become a huge stressor and user on our streets, and not just with rideshare, but also with the rise of e-commerce deliveries and food service deliveries. And these are a couple examples of how we actually fail to accommodate those users on the street. Like the image on the left, sometimes it causes more conflicts with traffic. And Alex and Jennifer are going to go into a little more detail on the importance of how important this is to our new types of mobility as well. And when the spaces are designed just for a single use, like truck loading or signed only for pickup and drop off for food delivery, they can tend to go unused during periods of time and really just aren't the best and most practical use of the space at all hours of the day. And this type of design and thinking maybe isn't necessarily that new, or nor does it need to be limited to just to our urban core areas. The picture on the left is in New Orleans, and it is literally a 400-year-old street, which is accommodating pedestrians, bicycles, cars, landscaping, and was the site for autonomous shuttle demonstration project as well. The picture on the right is Lancaster Boulevard in California, and I think this is a really great example of a suburban location. And this is a shared street or WUNRF. Here we're accommodating 2 lanes of travel plus ample parking both in the center median area as well as parallel parking on the sides. But this street could also function beautifully with the street closed to traffic as pedestrian only, or even as only as a bike boulevard. We've talked a lot about streets, but trails can be programmed as well. So the picture on the right is the CV Link in California, which is a multimodal mixed motorized path. It can accommodate low-speed vehicles, some of which we saw at the beginning of the presentation. And this runs parallel to a highway and provides an alternative network for those users as well. Sometimes we have constraints with the actual road, and shared spaces cannot be accommodated, like the photo on the right. And these really make the case for programming shared use paths that parallel our road network. Either of these examples would be good for the e-bikes or the scooters, which can go up to 20, 25 miles an hour. At some point, you may want to start making heavier investments and move away from movable solutions to something more permanent. Here's a couple of examples of some more permanent bike lane, green bike lane striping, as well as truck turning radiuses that still are flexible, but incorporate safety as well. And depending on the success and the needs of your project, or the success of any of your programming elements, at some point you may want to move away from these demonstration or quick build stages that we're looking at to more permanent solutions. So with that, I'm going to turn it over to Lisa, who's going to talk a little bit about the digital and economic ways that we can program streets. Lisa?
Okay, next slide. And again, welcome everyone to this presentation. So what I'm going to do is look at both technology and economic parameters as we look at how we can program our streets. We're going to start off with parking. So parking was actually an early target of a lot of digital innovation. So of course, in your pocket, you might have an app like ParkMobile that really revolutionized our ability to locate and pay for parking in one simple app. 1.0 technology also included parking sensors, and that sensor technology is getting better and better. It's really pretty useful within garages, so with those red lights and green lights. Even though what we found is that in some of the open street designs, that they weren't as durable as we were hoping. So again, wherever there's a problem, there's an innovator. And so some of those sensors are getting better and better. We're now moving to a new era of 2.0 with parking and technology. And we're moving from thinking about parking from individual spaces to actually a system within a district. And this actually does a lot of things for us. First and foremost, it means we can manage all of the spaces and better manage those spaces of the inventory we have. So the pressure to add more capacity is diminished because we're just managing what we have better. The second thing it allows us to do is dynamic pricing, which sets the price of parking based on the demand. You always want to have open 15% of your spaces or one space per block. And so that allows us to actually match supply and demand and use pricing signals to better manage that parking. Next. So related to parking is this new field of curbside management, which started to come about once we noticed an increased demand with ride hailing like Uber and Lyft, and then of course with e-commerce. Whenever you start a curbside management program, the first thing you really must do is inventory all the assets on that curb or on the sidewalk. And in the beginning, that was actually really difficult to do, very time and man-hour resource intensive. So one of the things we've been doing at WGI is leveraging, for example, LiDAR. Either on a car or even in a backpack mount, where we can go out and easily do a map of all those assets. To take it one step further now, the Open Streets actually introduced something called CurbLR, which is a data standard for asset management alongside curbs. So what you see in the one picture may be just a meter and a sign, but CurbLR translates that into an open source code. And that's good because it means all sorts of entrepreneurs can have access to that data and start crunching it in new and innovative ways to help cities figure out what to do with this really precious resource. Next. So in addition to inventory with curbside management, there is the ongoing programming you need to do of measuring, monitoring, and management. And these are just two different ideas, even though this field is growing rapidly. So with the image that says computer vision, this is a inside mounted camera that CurbFlow is beginning to offer customers. And what that does is it allows them to constantly videotape that curbside to figure out what the flow of users in and out of that curb is. Increasingly, a lot of these companies are using machine learning so that they can actually crunch that data for predictive capabilities and other ways to capture revenue alongside that curb. By being mounted inside, it's also protected from the elements. It's not subject to vandalism. And so this is becoming popular along main streets and other street segments and blocks where you've got so much activity at that curbside. Of course, moving forward, it also could be the basis for that new revenue stream along curbs that we've always actually gathered quarters or what have you for parking meters by the hour. But what we're seeing is a push to get that revenue collection by even the minute based on some of those quick pickup and drop offs of people and packages. On the right, this is a great image from the American Society of Civil Engineers showing some ideas about what a dynamic curb would look like for allocation throughout the day, just based on what that block face should be used for. So as you can see, there could be transit, there could be pickup and drop off, there could be pick up and drop off for rideshare, and of course that hourly parking where you have a clear sense right there on that signage about how much it's going to cost you and exactly where along the curb that parking is open. And that again it's not for every street. It could be just for some of those streets where you've got all that activity that you need to manage, or because you have such valuable uses along that street that it justifies this intense programming. So that's just a really good example. Next. Let's talk about digital infrastructure, because this is something that we've started to piecemeal together, but it really does merit looking at as a system. Of course, the 1.0 version is Wi-Fi with some of the antennas, but now with the popularity of 5G phones and with video streaming, and of course with the rise in connected and autonomous vehicles, we really need to build up that bandwidth that's needed along these boulevards. One thing to point out is that first and foremost, digital infrastructure is extensive. It includes electricity sources, it includes broadband, it includes assets above and below the ground. It's also very controversial because at the federal level, the FCC has actually issued preemptive legislation that limits the ability of a locality to select design and location of these small cell networks. And just to be clear, some of these small cell networks aren't all that small. So what we're trying to do in this image is to describe the variety and the extent of these assets. So starting at the bottom, of course, we're all familiar with the underground broadband that's coming into our city, or has been there for years, if not decades. There's a lot of innovation now there, including something called micro-trenching, where Crown Castle comes in and they do a shallow trench so you don't have to tear up the whole entire street. There's also a company called Traxel that does surface mounts for first last mile. And then, of course, once you get away from that heavier fiber, Then you get into this world of small cell arrays, and they can be pole mounted, which they usually are. They can be conventional antenna, but now you've got entrepreneurs who are building this hardware into architectural features. So that way they blend in with the background and you don't really notice it. And in fact, a lot of places send up drones with the small cells on them. And this is good for use during events or other times when you have that burst of activity. It's also good for emergency response as well. This is going to become a bigger urban planning issue in the years to come. And we think it's a good idea to actually get out in the head of it and maybe even kind of think of it in the same way we think of other capital investments in the CIP, capital investment plans. Again, it's a network and it's interlinked and it deserves to be thought about up front. Next. And then finally, lane assignment. This is something that's been happening on interstate highways for a while, where you're driving down I-95 or I-66, and you will see these dynamic signs that will tell you all manner of information about crashes, road conditions, things of that nature. We think that there's a big future for some of these variable signage applications, not only on highways and not only as we get into a mix of driver and driverless cars, but these applications can actually fit in a local jurisdiction, a downtown. This image about dynamic lane assignment is from Cincinnati. And in this picture, you'll see a bus because there's a transit only lane along that curb lane, but only during rush hours. One of the ways that this application can be thought of is in this overhead mast arm, where you signal to drivers, pedestrian, bicycles, and transit operators which lane does what throughout the day. It could be which modes are allowed, it could be variable speed limits, it could be turning assignments, but it's just a way that we can actually literally program our streets on the fly. So with that, I would actually like to turn it over to Alex Exposito, who's going to talk about the linkages amongst his service circuit and what it means to have better, flexible, adaptable infrastructure. Alex.
Great, thanks, Lisa, and thanks everyone for joining. So there's a lot here, and we've touched different pieces of this over the years with some of our services that we have in different cities. And so I guess for a quick background, so Circuit, we're an all-electric last mile shuttle service. So we're focused very heavily on the last mile, really 0 to 3 miles. And I think there's a big difference between micro mobility and last mile. There's been a handful of micro transit type programs, not necessarily scooters, but other ones that I think have tried to do too much. And when you start going over 5 miles, that starts to just become transit and not micro transit. And so we're hyper focused on those shorter trips. And so one of the reasons that that's a focus of ours is because we historically it's difficult, it's pollutive, and it's expensive to move short distances. Walking isn't always an option. And so because of that, about a third of all vehicle trips in the US are 2 miles or less. Transportation is a huge contributor to greenhouse gases. Cities are a huge contributor to greenhouse gases. So we believe that if we can cut down on the number of single occupancy vehicles for these short trips, then we can really make a difference for the cities and for air quality and the general environment. On the next slide here, I think what's unique about our services is that we offer a full stack solution to our transit partners. So transit partners is kind of the umbrella term that we use, whether it's a city, a community redevelopment agency, a private development. Collectively, we dub those as transit partners. And so our full stack solution is custom designed to that client. That includes the app, which is fully customizable, but you'll see geo-fenced in this picture. So again, not trying to compete with other forms of transit, really be as complementary as we can, and make those connections, whether it's connections to distant parking, connections to existing transit hubs, or really just getting people out of their own single occupancy vehicles for these short trips and encouraging them. All of our rides are pooled to pool together and use shared electric transit for those types of journeys. I think getting back to sort of the turnkey operator thing is we really, roll up our sleeves and work closely with our customers, and we provide drivers, which are W-2 local employees. We provide the vehicles, which are all electric. We provide the technology, which is, again, totally customizable. And we handle the insurance and everything else. So it's built for the city or transit customer, and then operated and managed by us. I think, one of the things that we've learned over the years is that people like things on demand. I think Uber and Lyft have taught us that, but unfortunately that doesn't always work well in cities. And so it can lead to a lot of traffic and a lot of congestion. And so when we think about programmable streets, there's a number of use cases that come to mind. A lot of urban traffic, some studies show as much as 30% is the result of people driving around in circles looking for parking. So if there's situations where there's another parking lot that's off the beaten path and we can help with that 1 mile journey, then we can get somebody to park there. And that really ties into some of the more dynamic parking pricing that's taking place, where somebody might not be as discouraged by a parking lot that's further away if they know they have a ride to get to and from it. Other situations are transit hubs. So some of our customers have actually asked us to set up smart spots. So it's on demand, but the pickup and drop off spots are predetermined. And we can set those up so that it's actually driving traffic to and from those transit hubs, whether those are buses for longer trips or trains. And then more recently, we have been looking more into the delivery side of things. The city of Santa Monica, for example, is currently doing the nation's first green delivery zone. So the idea is that big internal combustion vehicles aren't doing those last mile deliveries, and we're fulfilling that last mile with electric vehicles or by foot or by pedal. So there's a lot here, but I think that it's really interesting to see how cities are evolving and how people are enjoying these new technologies as a way to get around easier, but also to do so in a way that's more responsible as we look at what the city looks like with growing populations and new developments.
All right, now we'll move over to Jennifer Foote from BEEP to go over their operations and how they look at infrastructure. Jennifer?
Thanks, Lisa, and thanks everybody for joining us. I'm really excited and honored to be part of the presentation today. So a little bit about BEEP. We were founded in 2019 in Lake Nona. We're a technology managed services company focused on first and last mile solutions, very much like Circuit. We're using electric autonomous enabled shuttles. We sort of consider this micro transit as well. We're very focused on, that 12-minute city or those places where everything you need is within a 12-mile commute, either by a multi-passenger shuttle, a short walk, a scooter ride, or a bike ride. Some of our target markets are planned developments, again, that 12-minute city, and our home in Lake Nona is very much one of those planned developments, but also educational and business campuses, military bases, and places like that. Our company was founded by a group of serial entrepreneurs in the tech and transportation industry who've built their success really on looking at emerging trends and placing their bet in a niche market within an emerging trend. Thus, this focus on this first and last mile transportation gap, where many public transit companies either can't or won't go just simply because of the cost to do so, as Alex mentioned. Alex, you made my job a lot easier explaining that concept. We located in Florida for a couple of reasons. One, the beautiful Florida sunshine, but two, Florida is a very innovative state. They are regulatory friendly in terms of allowing for autonomous vehicle demonstrations and testing, and even allowing these vehicles to operate on public roads, which we do here around the state of Florida and in other states around the country. And proud to say that we are leading the largest and longest running public roadway AV deployment project in North America now. We have 10 shuttles across 5 routes, which we do believe is the largest of its kind in the country. Now, we are a system integrator of sorts, so our founders looked at all of the pieces and parts required to deliver a first and last mile solution across a very diverse ecosystem of suppliers in the autonomous vehicle space. And we realized that it would be rather difficult for a public transit agency, a planned community, a university to go out and reach to each of those individual partners and put a solution together. So we are a turnkey solution, technology enabled. We manage the assets. We provide the drivers, the shuttles, and we also provide service hour monitoring and support, maintenance, insurance, all of those things that comprise a comprehensive service. Now, we believe our role in the industry is an important one because we're able to safely leverage the current technology while also learning out on the open road what needs to improve to enable full autonomy. We have strong relationships with our partners. You'll see we have a Navia shuttle in the image here. We have a couple of other partners in this space. And because of those relationships, we're able to provide a feedback loop that we believe will move all of us along more quickly and most importantly, safely towards full autonomy in the industry. Next slide, please. So this is just a slide that talks a little bit about those partners that I mentioned: Navia, Robotic Research, Easy Mile, Local Motors. We've traveled tens of thousands of miles, interestingly enough, in those very short trip sequences of 1 to 2 miles. Our maximum route, I believe, is 1.2 miles in one direction. So a 2.4 mile round trip. And we do know that statistically, that's where most passenger vehicles are used, and also most accidents are within 2 to 3 miles from home. So we're really passionate about bringing a safe, eco-friendly solution to the table. The little markers you'll see on the map are where we have current deployments. We do have a deployment actively in progress out in Yellowstone National Park. And we have several other deployments in the state of Florida and around the country, either active or past deployments, as well as several opportunities that we're looking at in the southern half of the United States. Next slide, please. So I wanted to orient you guys to some key terms related to the autonomous industry, and it'll kind of set the tone for why we believe programmable streets are really important to expanding our business as well as the business of our suppliers. So the operational domain design is really the operating conditions under which a given driving automation system will function most optimally. So our suppliers provide us with an operational design domain, or an ODD, and it basically tells us where and when it's most optimal to operate the shuttles. The shuttles are fully autonomous enabled, meaning under the right conditions, they can be driven without a driver at all. Regulatory conditions now require that we do have a safety attendant on board, but in many cases, we've seen that we can operate up to 99% autonomous mode, which is spectacular, but there's still room to grow. And then the ADS, the automated drive system, which is collectively the hardware and software that's capable of performing all of the real-time operational and tactical maneuvers to operate on public road environments in real-time traffic. Whether or not it's limited by a specific operational domain design. So just a little bit about that, and I'll refer back to these things as I proceed through the rest of the presentation. Next slide, please. So, the current ODD does present some challenges for us. First and foremost, we're on a pre-programmed route. So if you think about some of the really cool things that Lisa and her team and Alex was talking about, dynamic lane assignment, dynamic curbside management, digital infrastructure, all of those things mean that the environment is changing all the time. And so with the current ODD, it's a pre-programmed path that allows the shuttle to operate. And so one of the major things that needs to happen within that feedback loop, and one of the reasons why we're so excited that we have that relationship with our partners, is to help them understand as well what's coming from the infrastructure side of the house that they need to be ready for to allow the shuttles to operate more ubiquitously in autonomous road around the country. But a couple of other things that programmable streets can help. So right now there are some lane requirements. The lanes have to typically be a minimum of 10 feet wide and well marked so that we're able to gauge where we are on the pre-programmed path. We like to avoid on-street parking. If we can't avoid it entirely, it simply means that we, can you go back to the previous slide, please? It means that we just go at a lower speed, which then degrades the customer experience. And so these are things that, while it's doable from a technology perspective, it may not be most optimal from a customer experience perspective. Making complex intersection maneuvers, lane changes, yields, unprotected left turns are things that we typically like to avoid with the current technology. We also like to avoid major traffic if possible, and making sure that we're avoiding lanes that are maybe shared with cyclists or scooters. And so you can see that the recommended operational domain design is somewhat restrictive given the current maturity of the technology, but also the current maturity of programmable infrastructure in the environment that can then communicate back to the shuttles. So next slide then talks about some of those areas where we believe that programmable streets can help. So when we talk about dynamic curbside management, one of the things that came to mind is if we know that within a certain hours, it's going to be restricted to loading zones for food deliveries or supplies deliveries. If we're able to have that two-way cellular vehicle to infrastructure communication, we're able to tell the shuttle, hey, you need to recognize this lane is going to be closed, and the shuttle can then operate more dynamically by going around, sensing its environment and making those decisions to move out of a lane and around when it's safe to do so. Thing with, programmable parking and how those things change. So allowing communications from parking meters, for example, if someone has chosen to park for a certain period of time, the shuttle can receive communication that says the risk is lower. Nobody's expected to leave within the next hour. Perhaps you can continue at a higher speed rather than slowing down. Obviously, having infrastructure that signals to the shuttle that it's safe to make a turn or safe to maneuver in a complex traffic situation is certainly going to help. And then having situations where you have additional cameras or things on those, digital infrastructure, dynamic lane assignment will communicate to the shuttle, hey, this is a time when you're free to operate without risk of pedestrian or cyclist interaction. This is a transit only lane between these 2 hours. And from a safety perspective, I can even imagine that there's a safety mechanism that prevents the shuttle from being dispatched in hours where a transit lane isn't enabled. So there are all sorts of really cool and unique things that can be done with dynamic infrastructure, dynamic lane assignment that not only expands the operational design domain, but also makes autonomous transportation safer for the community. Next slide, please. I think we're back to Lisa now.
All right. So we did have a question in the Q&A talking about what is the role of public transit. And so we're going to talk about this a little bit here in this rendering. We thought we would pull everything together by talking about a situation where you have a building and you have people and you have a street. So how is all of this going to work together? And in this rendering, what we tried to do was to develop a mock-up of a curbside where there was a lot of things going on, but that also addressed some of the things that Alex and Jennifer talked about. So in this case, if you look at the curb, going from left to right, you can see there's landscaping. We've got 4 car share spaces there for this building, which is actually purposely designed to be car light or even car free with no parking. And then what your front door is literally your mobility system where you can do car share and bike share, scooter share. You've got a mobility room on the first floor. And then of course, you've got a transit stop and then those bollards. So next slide, please. We'll take a closer look. So going from left to right, we included something called AV legible curbs, and this is actually an image from NACTO. And what they have been doing is creating curbside designs where the curb meets a lot of these shuttles, some of it for ADA compliance, some of it for level boarding, which just has a good feel when you're getting on a transit vehicle, but also we're looking at machine readable curbs. So is there something here that we can build into the environment that an AV can read instead of having to go through a lot of complex calculations? So that's one example of things we can do. And notice that it doesn't degrade from the aesthetics and the really character of the area. The second with this amenity car share, we're big fans of Envoy, which is an amenity car share company that only supplies cars to individual buildings or campuses. And again, it's those cars for the people in this building to make it something that is transit and mobility ready. We've got activity buffers here. In fact, that's what those little purple plants are. Keeping in mind that early discussions on separating pedestrians from AVs, there were a couple of technology companies that recommended that you put a big fence along the curbside to keep pedestrians out of the road. And we don't believe that's a good solution. But we do actually have a lot of sympathy for making sure that we have that separation and that safety. So things like low slung plants can help guide pedestrians along the sidewalk and hopefully minimize jumping in and out of the street. We've got real-time information, which could include other transit vehicles that are pulling up and accessing this curb. So it could be a city bus, it could be an employee shuttle. It could also be listed on that sign where the virtual pickup stops are that Alex referenced. So you know where exactly to stand so that your driver on circuit can come pick you up at the right place. And then finally, that flexible infrastructure of bollards that can go up and down. And yeah, we were talking about Victor Dover and his design, and he included those in Clematis Street in West Palm Beach, and they work lovely. So this just kind of sums it up. But if you'll stay on this slide, I wanted to invite Alex and Jennifer, if you have any comments about sort of the curb or anything that we didn't emphasize enough. So Jennifer.
Yep, absolutely. So first of all, I think one of the things as we deal with the regulatory restrictions right now around AV travel, there is a great deal of concern around how do we segregate pedestrians, cyclists, and other vulnerable road users. So I love what you guys are doing with the plants and the activity buffers and things like that. I think one of the things that's super important as well is, again, this real-time information and the two-way, the ability to take two-way exchanges between the information systems and the shuttles, which can moderate speed potentially when it's approaching a high pedestrian area or a cyclist. So I think those are really critical things that helps to moderate from a safety perspective. And I think community education is super important as well, Lisa. I know this is something that you're really passionate about. And we share that passion in helping the community understand how all of this keeps them safe or safer. You know, one of the things that we provide as part of our service is informing the public of how autonomous vehicles work, and also providing that monitoring that I mentioned. So every hour that we operate, we're monitoring using cameras inside and outside the vehicles. So the risk is low. There's not a risk that the shuttles are going to run rampant. But even as we begin to build this communication network between the smart infrastructure that you guys are speaking of and the shuttles, there will be a command center that monitors constantly this communication mechanism between the vehicles and the smart infrastructure, such that if the communication network goes down and it's not, that communication isn't happening, everything kind of stops until a resource is dispatched, and that dispatch is instantaneous. As soon as an alert comes through, hey, this isn't working the way that it should, somebody's on the scene to get that resolved. So I just really love the possibilities from a safety perspective, from an efficiency perspective, and from an environmental impact perspective of everything that's put forward here.
Fabulous. So Alex, you talked a lot about, I guess, commingling people and packages. Can you talk a little bit more about what you see with that? Because it seems like it's complex, but something that makes a lot of sense.
Yeah, you know, so not to distract the conversation from moving people, because that's really, you know, our main focus. But we have an existing operation in Santa Monica, and so that one sort of fell in our lap. And with ridership down a bit due to COVID, if we can use that same infrastructure to move people or packages, infrastructure meaning we already have the cars there, we already have a team there, a garage, then it's a great way to kind of maximize efficiencies and stack two business units essentially on top of a previously established infrastructure. So it's been interesting to see how packages have impacted traffic. And what's been really interesting is how disorganized it can be in a lot of cases. I was in New York City a few weeks ago, and I was going to the office early in the morning. It was probably 7 o'clock, and there was a rider truck on the side of the road just throwing packages onto a sidewalk, and a bunch of couriers there collecting them. And mainly Amazon packages, but it's, you know, we obviously saw this huge growth in delivery demand. But now I think that opens up a lot of questions around what's the best way to handle this demand. And as I've looked more into it, you know, if you move, on average, I think Business Insider says that 53% of total shipping costs occur in the last mile. So it's not only problematic from a traffic perspective, it's also problematic from the recipient and the sender's perspective in the high costs that are there. So as we continue to plan safe streets, I don't think the delivery trend is really, you know, it might die down a little bit, but I don't think it's going anywhere. And just like you want to plan sidewalks, you know, you also might want to consider, where do the big trucks stop so they're not driving around in circles and double parking and creating more traffic?
Okay. We have a fabulous question here from someone who wants to know, how do we anticipate that working on a day-to-day basis? And would it be the Department of Public Works? Would it be a contractor? How much will it cost and how complex will it be? So Jennifer, can you take that one?
That's a great question, Lisa. Thank you for giving me that one. You know, I think that we are probably a few years out from this happening. I think that one of the things that our government is recognizing is that there's an investment required to enable this. You know, as far as the cost of doing it, I don't know that anybody has a great estimate on that. But I think that in terms of who does it, it's going to be a collaboration between public and private agencies. So there are a lot of players in the ecosystem that would have to bring something like this together. There are 3 providers on this call just talking about the concepts of this. And so I think that it's really going to require a great cooperation between our public agencies, between private companies like ours, and then getting standards in place such that there's intelligent communication that's consistent across every type of infrastructure. So I think it'll take a little time, but I do think it's coming at us a lot faster. And I'm thrilled to see that the government is making investments as we speak, even to enable the local municipalities and cities to begin to think about how to implement this and make it possible.
Awesome, thanks. And for both Alex and Jennifer, we have a question about passengers a day. What's your utilization right now?
It varies. For us, it varies so much by market, where in some markets, we've limited pooling. So that has definitely hurt efficiencies, but it's done for safety reasons. So we're only pooling if each group has its own divided row. That said, it's definitely been coming back. And the other factor for the markets is San Diego is 14 hours a day with 18 cars downtown. You know, other operations are a few days a week with just a few cars. So long-winded, not answer to your question. In Hollywood, we're seeing ridership climb back to about 12,000 a month, which is still 20% down from where we were. But I think part of that is the result of it not running as efficiently with pooling.
Yeah, and Alex, I agree. We've seen a dip in ridership because of COVID restrictions and social distancing on the shuttles. You know, we can have upwards of 300 passengers across a 6-hour shift per shuttle, but it really depends on the use case and the location. So, and that, you know, that's a post-COVID recovery number. And we're seeing ridership tick up week over week consistently since we came back in operation in June.
Great, and I'm going to end it up with a question for both of you. We certainly may have people who are like, wow, I really want Circuit and Beep to come to my town. What tips do you have about how to get ready for some of these services that are digital, and really what should they be talking about to their city or county manager, their Department of Public Works, and their transit agencies?
Yeah, I mean, I can hop in first. I think a few things that immediately come to mind is the focus on multimodal options. I think oftentimes transit agencies look at how can we just have a blanket solution. But a scooter is a great way to get around for some, but not for everyone. And so you need to have alternate options. I think the other thing is there can be concern from transit agencies about it competing with their existing services. And so I think, understanding what those use cases are so that they're designed so that doesn't happen is also important. And then, ultimately, it's a great return on investment. I mean, TRB has done countless studies about the economic return on the investment in transportation as it relates to economic development and job creation. And so oftentimes, oh, that's going to cost a lot of money is the initial knee-jerk reaction. But when you actually start to dive into where it can help save money, how it can help promote economic activity, all of a sudden, that sticker shock starts to be relieved a little bit.
Yeah, that's a great point, Alex. And one thing that I would suggest is working with a partner that specializes in smart city infrastructure and how that enables transportation, like WGI, and working on developing those business cases that help support that initial investment. So I agree with you 100%, Alex, that we've seen in some cases that there's a sticker shock, but when you really dive into what that means in driving economic development, even as a way to activate real estate in the area and bring new residents into an area because of the multimodal options, it really makes a compelling case. Another thing that I think would be important for folks is to recognize that the evolution in the industry, particularly in autonomous and digital infrastructure, it's happening daily. It's happening quickly. And while, I can readily admit that, there are some things that we can't do with an autonomous vehicle right now that we may be able to tomorrow or the next day. So having realistic expectations about that operating domain, and how we've found really creative ways to leverage the technology safely and set customers up to evolve as the industry evolves. So having realistic expectations and then being flexible and ready to move forward as the industry evolves, I think is something everyone should keep in mind.
We have one last question here that I'd like to touch on briefly before we wrap up. And the question is, how are we addressing equity and justice with these policies and plans? I don't think any of these solutions are the silver bullet to solve all the problems, but Jennifer and Alex touched on a few things here that I'd like to point out. A lot of these techniques are looking to increase livability and to increase, the character of our communities, bring our communities together. So, we're not just focusing on moving people in and out, we're focusing on, developing the livability of our neighborhoods. And it's also an opportunity that maybe we can bring investment and economic drivers into new areas where maybe we wouldn't have had them or had that opportunity before. And I think any time that even small, how we can increase options for people, none of these things are maybe perfect for everybody, but when we can start providing more options and providing more network connections for people, we start to really, hopefully this is at least a step in the right direction for that.
Jennifer, did you have something to say?
Yes, there was a question about grant funding for the public sector, and the answer is yes. In fact, we've supported some of our customers in putting use cases together for grant proposals and have helped our customers win $20 million in grants to date. So certainly with all of the infrastructure funding that's coming, there is a huge focus in environmental justice, in equity, transportation equity. And so those are things that will be top of mind when applying for grant funding.
Yeah, and I think just to add to that, fortunately, this area is getting a lot more attention now from grants, from cities. Unfortunately, it's really a perfect storm of problems. I think historically you've seen disadvantaged neighborhoods are either built near highways or industrial centers where air quality is already bad. EV adoption is typically a lot slower in disadvantaged communities, which is unfortunate because historically EVs have been looked at as more of a luxury item when in reality they're actually a lot less expensive to operate. And oftentimes those areas are in transit deserts. So you have this problem where air quality is bad, access to mass transit isn't good, and EV adoption is slow. And so for all those reasons, it's been getting more attention. One of the things that I think is really important is keeping the prices low. I think unfortunately, people don't realize that mass transit isn't a profitable business. And the idea of making it less expensive by increasing fares can actually have a negative impact on your cost per rider, because if that fare increase reduces the demand from the riders, then you have less riders and your cost per rider actually goes up by you increasing that fare. So keeping those fares low to encourage that utilization and encourage that ridership, I think is incredibly important in disadvantaged neighborhoods. And it obviously helps, reduce commuting costs too.
Well, that's all the time we have today. I want to thank our hosts and all of our visitors for participating. We're glad to have you join us today. You can find more about WGI on our website at wginc.com. And we're on all the major social media platforms, including Instagram, LinkedIn, Facebook, and YouTube. Thank you again for joining us, and we look forward to meeting soon.
Thanks for having us.
Thank you.